The next session is based on control statements or decision-making statements. We have different types of decision-making statements. I have listed them here. We have simple if, multiple if-else, nested if, switch, and ternary operator. We will start with the first example of simple if-else. Now, what is this control statement? Control statement is basically used in your program when the program has to take a decision of which statement should be executed and which statement should not be executed. So generally, whatever examples we have written till now, let's say you have written a program of 10 lines, when you run the program, all those lines will be executed one after the other. Nothing will be left out. All the statements will be executed. But many a times, we might have multiple solutions, or we say multiple cases. Let's say we have 2 cases, and out of those 2, only one should be selected at a time based on some condition. So what we do is, we write both the cases, and based on the condition, we tell the program to pick either one of the solutions. So to do that, we make use of your if-else. As an example, program of taking marks of 3 subjects, calculation of total, average, and printing them. To that, I want to add an additional feature. Let's say I want to also give whether the student has passed or failed. So now how many cases we have? 2 cases, pass, fail. Will both be applicable to a student at the same time? No, only one will be applicable. So based on what condition? Now let's say if average is less than 35, it should be fail, otherwise it should be pass. So we have a criteria or a condition. The condition is what now? Based on average less than 35. So what we will do is, we will write both the solutions and tell the program to pick up any one of them. So let's see how to do that. So this is a problem definition. For a student, input marks of 3 subjects, calculate total average and print them. If average is less than 35, print fail, else print pass. Let's see how to do this. So I already have some part over here. So input PCM, calculation of total, average, and print them. Now, how do I write an if statement to decide whether it should be printed as pass or fail? So we make use of the rhombus symbol. So within a rhombus, we use a new word, it is if. If average less than 35. If it is yes, what should the computer do? If it is no, what should the computer do? So if the average calculated falls below 35, if it is yes, then the conclusion is print it as failed. And notice the double quotation. If it is no, that means average is not below 35, you are saying it is print pass. Now whether it is pass or fail, it should get connected to stop. I will not give 2 stops. I will give only 1 stop in the flowchart and make both the statements connect to the same box. Now, let's understand how this works. First time, when I run this program, maybe I'll give the input as 60, 60, 60. This is PCM. Total is 180. Average is 60. So this is total and average. So up to this we know. Now let's understand how this is calculated. If average less than 35, what is average I got? 60. 60 less than 35. Is that statement true or false? Now, if average less than 35, what is the value of average I got? 60. 60 less than 35. Is that statement yes or no? No. 60 is not less than 35, so it will go to the no direction. It will print it as pass and come to stop. So now I get the result as pass. Is it correct according to the problem definition? Yes. And also notice it has not come to this part of the code at all. It has ignored this fail. Let's run the program for the second time. And let's give the values as 20, 20, 20. So the total is 60. Average is again 20. Up to this, we got the average. Now, if average less than 35, what is the value of average? 20. 20 less than 35. Is it true or false? Is it yes or no? Yes, 20 is less than 35. So it will always go to the yes direction and it will now print it as fail. From here, it comes to stop. And notice that it has not taken this part of the code at all. So at any given time, it will do either one of these 2. It can never do both. Let's take another one. I'll give 35, 35, 35. Total is 105. Average is 35. It will print total average. Now come over here. 35 less than 35. Is that statement yes or no? No. So it goes to the no direction. It prints it as pass. From here, it comes to stop. Is it correct? Yes. So this is how we specify it. We write an if statement, we give two solutions, and the program is capable of making a decision whether it should go to yes or no based on the condition. Now, one small concept over here, the symbol what I have used, less than, this is called as relational operator. So we're getting introduced to one more type of operator called as the relational operator. So less than is one operator, then greater than, less than equal to is written one beside the other, greater than equal to, if you want to check if two values are same or not, you have to use double equal to, not single equal to, it should be double equal to. And the last one, exclamatory equal to, is known as not equal to. Now, let's say the C program for this. Let's see the C program for this. I have written the first part already. We know how to do the input, calculation and print. Now let's see how to write the if statement. So what is the condition? Average less than 35. So if is a keyword, put a parenthesis. The condition should always be within parenthesis. If average less than 35, no semicolon, then press enter, put a pair of curly brackets. This is for the yes part. After the curly bracket, put an else, no semicolon, and followed by a pair of curly brackets. This is for the no part. So what is the S part? It should come within the first pair of curly bracket. What is the message? The message is fail. Else, what is the message? Else indicates the no part. So this is pass. So let's analyze the code once again. If average is less than 35, if it is true, it will do whatever is there in the first pair of curly bracket. If this condition is false, it will directly jump to the else part and it will do whatever is there in this pair of curly brackets. Let's run this program. 78, 89, 90. So average I got 85 point something. So the result is pass. Is it correct? Yes, it is correct. Next, let's test it for the fail marks. 12, 23, 33. What is the average? 22.66. So what is the result is taken as fail. Let's test for one more. The last one, 35. 35, 35, 35. So what is average? 35. What is the result taken as pass? So this is how you write your if else, and when you write the code, see to it you check the code for different values of PCM so that you can be sure of whether your code is correct or not. Let's take a second example. The problem definition is we want to take the age of a person and check whether that person is eligible to vote or not eligible to vote. The age limit is 18. Now, how many inputs for this? One input. How many results we have, or how many solutions how many cases we have? We have two cases. Will both the cases be applicable for one person at a time? No, only one of them. So we need to make use of an if else. So let's see the flowchart for this. So start input age. Now, based on the age, I should decide. So let's put a rhombus. And what is the condition? If age is less than 18, if it is yes, what should the program do? If age is not less than 18, what should it do? So if age is less than 18, then we can come to the conclusion that the person cannot vote. So I will say print not eligible to vote. If it is no, that means age is not less than 18. So that means the person is eligible to vote. So here I will say print eligible to vote. And after this it is stop. So we will not put two stops. We will put only one stop and connect both the statements to the same stop. Every time we write a code, we need to, every time we write our flowchart, we first have to do a test to check whether it works correctly or not. We call this as a dry run test. Dry run test is, we are not testing it on the computer, we are just testing it with our flowchart on a paper, on a piece of paper. So first time, I will give the input as, let's say, 25. Age is 25. Now it comes to the if statement, it checks if age less than 18. What is age? 25. 25 less than 18. Is it yes or no? No. So it goes into the no direction. What does it see over there? It says eligible to vote. So is this correct according to our problem definition? Yes. If it is not below 18, it is eligible to vote. Second time, I will give a second input. Let's say I will give it as 12. Age is now 12. If 12 less than 18, is it true or false? It is true. Yes. So it goes into the yes direction and it will say not eligible to vote. Is it correct? Yes. Third, I will give the input as 18 itself. Now, if age less than 18, 18 less than 18, true or false? False. Go to the no direction. So it will say eligible to vote. Now, it's up to you how you're going to give the condition. I gave it as age less than 18. See, you can also do it like this. You can check for greater than equal to 18. If you're checking for greater than equal to 18, that means if it is greater than 18, what should you write for yes and what should you write for no? You have to interchange that. You can choose anyway the relational operators, but see to it that you give the correct statements for the yes and no part. So I'll just put it back to the original one. So this was our flowchart. Now let's convert this into C program. So I already have declared a variable and I've taken the input. Now let's write an if statement. So what is the if syntax? If, put a parenthesis, age less than 18, no semicolon, a pair of curly bracket of what should be done if it is true, followed by else, again no semicolon, and a pair of curly bracket for the else part. So if age is less than 18, double quotation, what are we saying? Not eligible to vote. Else, printf, this is eligible to vote. Let's check this. First time I will give 12. So it is saying not eligible to vote, correct? Yes. Next, I will say 23. Is this eligible to vote? Yes. Let's check for 18. Is eligible to vote. Let's look at the third example. One of the most common examples in if-else. Input an integer and check if it is an even integer or an odd integer. How many inputs? One input. How many cases? Two cases. And only one of them should be implemented at a time. Now, on what basis we tell a number is odd or even? So we do it based on the reminder. Suppose if I give you the number as 8, 8 is even, you can tell that easily, but mathematically how do we prove that? So calculate the remainder. So 8 divided by 2, 8 modulus 2 will give me 0. So if the remainder is 0, you say it is an even number. Next, suppose if I take it as 7, what is 7 modulus 2? The remainder is 1. Remember, modulus works only with integer, you cannot do it with float. And the answer will always be an integer when you divide a number. So 7 modulus 2 is 1. So the remainder is not 1. So the answer is going to be odd. This is how we are going to do it. So let's see the flowchart for this first. So input A. From this, we are going to extract the remainder. So remainder equal to A modulus 2. Then next, what should I do? I should check the value of remainder, what I have got, and then decide based on that what is the result. If remainder equal to 0. Now pay attention to this. Here we have to use double equal to because we are not assigning 0 to remainder variable. We are checking if it contains remainder value as 0. So if remainder is equal to 0, if it is yes, what is the conclusion? If it is no, what is the conclusion? So if it is yes, if remainder is equal to 0, we will say that it is an even number. Else, we will say it is odd number. As usual, connect both of them to a common step. In this case, the common step is stop. Let's see the C code for this. Okay, I have taken an input. I have calculated the remainder. Then I will say if remainder double equal to 0, pair of curly bracket, else again pair of curly bracket. So printf, the number is even. Else, printf, the number is odd. So, and again, if you wish, you can put return 0. Right now, it doesn't matter. It will accept it even if I don't give this return 0. First number is 5, result is odd. Yes. Next, I will say 8. The result is even. Now, I want to show one more way of writing this code. What you can do is, you need not do the calculation separately for the remainder. You will say, remove this remainder step calculation. Directly in the if statement, you can also say A modulus double equal to 0. So, this is also one of the common methods used by many people. Let's check whether this is right or not. 6 even, 9 is odd. We understood simple if else, that is how to use one if else. The next topic is multiple if else. The name itself indicates we are going to use more than one if. When should we use more than one if? We understood that a single if is used when you have two solutions and you choose any one of them, or rather, the program chooses any one of them. But what if your program has got more than 2 cases? So you have 3 cases, 5 cases, 10 cases. So in that case, a single if cannot handle it. So as the number of cases keep on increasing, the number of ifs also increase, and that is known as multiple if else. Let us say, I want it like this now. I want to input a number and check if that number is positive number, negative number. I also have another case 0. Let's understand what do I mean by this. Suppose I give the first input as 4. It should give the result as positive. Next time I'll give the input as -3. The answer is negative. If I give the input as 0 itself, what should be the answer? The answer should be 0. This is what we want to perform. Now, how do we write the code for this? Or how do we write the flowchart for this? Let's look at the flowchart. So I have one input A. Now, out of these 3 cases, which one I have to check? I should decide. I will decide on, I want to first check for positive. Okay, I will put a rhombus, check the condition. If A, how do we check a number is positive or negative? It is based on 0, greater than 0. If the number is greater than 0, then we can say definitely that the number is positive number. So print within double quotation, I will say positive. Okay, let's say the number is not greater than 0. The condition is false. If it is false, can I say that the number is negative? No, it may be negative or it may be 0. So between these two, I should introduce one more if. So in the no part, I will write it below. In the no part, put another condition. Now what should be checked in this condition? We have to decide out of these two which one we want to check. I want to check for negative explicitly. So I will say if A less than 0, if this condition is true, if this condition is satisfied, then again we can say definitely that the number is negative. There is no other confusion in this. The number is negative. Now, if this is also false, then it means the number is not positive, the number is not negative. The only conclusion is the number is 0. So I need not put another if statement. I have one more part left out for the second if, that is the no. So in the no, I can directly say print. What is the result? Result is 0. Now connect them to stop, and be careful when you're connecting it to stop. Don't connect positive to negative like this. This is not correct. After printing positive, we have to come to stop. So come from the outward direction. Come from the outward direction and connect to stop. So the lines are very important. They show how your logic is flowing, in which direction it is going. So be careful where you are connecting. Now let's do a dry run test to check whether our values work correctly or not. The first input A is, I will give it as, let's say 4. So it comes to the first if statement. 4 greater than 0. Is it true or false? True. So it goes to the yes direction and it will give it as positive, and from there it comes to stop. Correct? Yes. Second input, maybe I will say -3. A is -3. It comes to the first if. It cannot jump directly to the second if. You have to remember that. It starts with the first condition. -3 greater than 0. Is it true or false? False. So it goes to the no part now. In the no part, there is another condition. It now checks if -3 less than 0. Yes, this is true. Now it comes to the S part and it gives it as negative, and from there it goes to stop. Third case, I will give 0. Input A is 0, starts from the first condition. 0 greater than 0, no, it comes down. 0 less than 0 is also no. So it goes into the no direction and it gives the result as 0. So the dry run test shows that whatever values I have taken right now, they are working correctly. Let's write the C program for this. So I have already one number input. Now, first condition same, no changes, A greater than 0. If it is true, what should be done? Now, see how the second if should be written. Else, space, put an if statement. And again, condition A less than 0. A pair of curly brackets for the S part of the second if. And then again, else. This else is for the second if. So, if, else, if, else. What should I write? First one, printf, it is positive. Else, this is negative. Else, the result is 0. So look at the code. I declared a variable A. I took the input scanner for A and then check the conditions. Let's test this. 9 is positive, correct? Next, 0. Yes, I got the answer as 0. Minus 7. The answer is negative. So this is how we write multiple if-else. I'm repeating, when you have more than 2 cases, then your number of ifs also increase. That is what is meant by multiple if-else. Let's take a second example on multiple if-else. The problem definition is, take any 2 numbers, integers a, b, and check whether a is bigger or b is bigger. There may be other possibility, both are equal. So let's understand first. If I give the input A as 4 and B as 3, output it should say A is bigger because 4 is greater than 3. Next, I will say 3 and 4. What should be the result? It should say B is big. Suppose I say 4 and 4, it should say both are equal. How many inputs? 2 inputs, A and B. How many cases? 3 cases. A is big, B is big, and both are equal. So let's check the flowchart for this. So I have 2 inputs, A and B. Now, out of these 3, which one I should check? I want to first check with A. So how do we write the condition? So we say if. So I want to check whether A is biggest, means I should check if it is greater than B. A greater than B. If it is yes, what is the conclusion? So we can say definitely that A is bigger. So I will give the message A is big or bigger. If it is no, does it mean that B is big? No. It might be B is bigger or both are equal. So in between these two, I need to check which one it is. So let me check for the second condition, B is bigger. So put another if statement. If B is greater than A, if this is true, if this is satisfied, then it means definitely that B is bigger. Print B is big. If this is false, then there is no doubt in the result. It has to be both are equal. Because A is not big, B is not big, the only option left out is both are equal. And connect all of them to stop. Be careful, come from the outward direction. And connect it to stop. Right? So yes, this is no. Second if statement yes, and this is no. Let's see the C program for this. I have declared 2 variables A and B. I have taken 2 inputs A and B, that is 2 scanfs. Now let's see how to write this. If A greater than B, if it is true, do what? Else if B greater than A, if this is true, do what? If this is false, do what? So if, else, if, else. Printf A is big. Next, second condition result, B is big. Third, both are equal. Let's test this. 4, 3. A is big. Is it correct? Yes. Next. 4, 5. B is big. Yes. 5 is greater, so B is big. 5, 5. Both are equal. Let's take another example on multiple if else. The problem definition is input any one day of a week as a number between 1 to 7. And based on what number we have given, we should print the weekday in words. If the input is 1, then print Sunday. If the input is 2, print Monday, and so on. So 1 to 7, we are handling the cases. Now, what if I give the input as, let's say, 100? It should say invalid day. If I say 0, if I say -1, it should give it as invalid day. Now, how many inputs I have? 1 input. How many cases I have? So, I have 7 plus 1 this invalid. So, I have 8 cases. So, how many ifs we will be using? We will be using at least what now? 7 if statements. Let's look at the C code for this. So, look at the code. I've kept it ready. Let's understand this. So, I've declared a variable day. Input that. It's an integer between 1 to 7. Now, if the given input is 1, then print it as Sunday. So, look at the syntax. Day double equal to 1, print Sunday. Else if day double equal to 2, print Monday, and so on. So, let's look at the 7th condition. So, I have all the 7 conditions written. If day is equal to 7, print Saturday. Else means if it is not equal to any one of the above, then print it as invalid day. So, let's look at the code. Input, conditions, and last. Let's check this. I will give the input as, let's say, 4 is Wednesday. Next, I will say 1, Sunday. What if I say 9 is invalid? So, as I said, the number of ifs, as the number of ifs grows based on the number of conditions. Take this as a practice example. The problem definition is input the marks of PCM subjects, calculate total average, print them. Now, the conditions are slightly different. I have increased the number of conditions. So, if average is less than 35, print fail. Then, if it is below 50, print grade D. Then C, B, A, else, print grade S. So, now, how many inputs we have? 3 inputs. How many cases we have? We have 6 cases. So, this is an example of your multiple if. Solve this. If you have any doubts, put it in comments.